Okay, we're moving on to exercise 3.4, and in this exercise we're looking to represent complex numbers on a graph or axis, if you like. And the graph that we use to represent complex numbers is called the Argand diagram. Now the Argand diagram has a real axis, which you've seen so far to be the x-axis, and an imaginary axis, which is the y-axis. And let's say I wanted to represent the complex number, I want to represent the complex number, we call it z, is equal to 2 plus 3i. Where would that appear on the Argand diagram? Well, what you do is the real part is 2, so we go up 2 units on the real axis. The imaginary part is 3, so you go up 1, 2, 3 on the imaginary axis, and you do your dot. And this dot represents the complex number 2 plus 3i. Now, we're often interested in finding the distance from that complex number to the origin. And this distance here, we call it the modulus of z. So the modulus of z. And how we denote it or show it is you've got 2 straight lines like that. Okay, so how do we find this distance here? Well, we're using Pythagoras' theorem, really. This distance here, because you're going up 3 on the imaginary axis, is 3. This distance here, because you're going up 2 on the real axis, is 2. So in order, we can use Pythagoras' h squared is equal to a squared plus o squared. And so we're going to say the modulus of z squared is equal to a, in this case we're saying is 3 squared, or sorry, we're going to say a is 2, and we have to square it, plus 3 squared. And then to get the actual z modulus itself, we get the square root of both sides, and you end up with 2 squared plus 3 squared. Now, if we were to make that a bit more general, what we would say is if z, the complex number, is equal to a plus bi, then its modulus can be found by squaring the real part and squaring the imaginary part. And that will give you your modulus formula, if you like. That's a general formula. Okay, so here that is modulus of a complex number. It's the distance, that's a typo there, from the point to the origin on the Argand diagram. The distance is found by Pythagoras' theorem. So this one here you've got to remember. It doesn't appear in the table book, where you just basically have to remember. And again, here's an example. This is the example I used. Z is 2 plus 3i. Then the modulus is got by squaring the 2 plus squaring the 3 and getting the square root. In this case, it turns out to be root 13. So just a little bit further on representing complex numbers in the Argand diagram, I'm just going to show you a few further complex numbers and where you would put them on the actual diagram. Let's say we had z equals 2i. Now this is 1, 2, 3, and we have minus 1, minus 2, minus 3. Now 2i, the real part is 0, and it's just the imaginary part. So you go up 2 on the imaginary axis, and that is equal to... Okay, so let's try another one. If you want to represent z equals 3, just a real part and no imaginary part, then you just go up 3 on the real axis, and your point is there. And again, just to show you how the minuses work, z equals minus 2 minus 3i. You go to minus 2 on the real axis, minus 3i on the imaginary would end up here. And this one is z equals minus 2 minus 3I. This one was z equals 3. Okay, so hopefully that's enough to get going on exercise 3.4. Do questions, just do my list of ones here I want you to do, just there. Questions 3, 5, 8, 9, 10, 12 and 17, and they're on page 107. Thank you.